Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners, and welcome to today's Natural Sciences lesson. My name is Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's topic, while we are still exploring the knowledge area, planet Earth, and beyond, we will be talking about the mining of mineral resources, right? And also our subtopic is the mining of mineral resources. Right, so let's quickly look at our lesson objectives now. Remember that this is what we need to achieve by the end of the lesson, right? These are the following things that we should be able to do when this lesson ends. Firstly, we should be able to explain, right? To explain how minerals are extracted from ore. Secondly, we need to be able to describe, right? To be able to describe the physical and chemical separation processes that are used in mining, right? We need to be able to describe the physical and chemical processes that are used in mining, right? Those are the methods of separation, right? Also, we need to be able to explain some of the negative impacts of mining, right? So all this information is found under the KEPS document on page 80. Right. Now let's look at our pre-knowledge, right? Our foundation to today's topic, right? Because knowledge builds upon knowledge, right? So now, in grade 7, we introduced the periodic table of elements, right? We said that it has all the known elements so far, right? All the known elements and that have been discovered so far, right? And there are about 118 in total, right? But that does not mean that this is the only elements that are existing on Earth, right? There's still more room for discovery as well, right? So just to mention some, we talked of elements such as hydrogen as the first one, right? We talked of elements such as boron, oxygen, and all the first 20 elements that we have discussed in our grade 7, grade 8, and as well as grade 9, right? Then also in grade 8, we discussed the topic of atoms, right? We said that atoms are the building blocks of matter, where matter is anything and everything that occupies space and has mass, right? So meaning everything that has space, that occupies space and has mass, is made up of these tiny particles that are called atoms, right? And these atoms, they are made up of subatomic particles, right? Which are the protons that are positively charged, the neutrons that are neutrally charged, and as well as electrons that are negatively charged. Then also in grade 8, we talked now about the relationship between the Earth and other planets in our solar system, right? So we said that we have 8 planets in total. To name them, the planets are Mercury, Earth, Jupiter, Uranus, Venus, Mars, Saturn, and also Neptune, right? These are the planets that we have discussed also in our grade 8 when we're talking about the relationship between the Earth and other planets in our solar system, right? Then also now in the very same grade that we are in, we talked about compounds, right? We said that compounds, they are made from different elements that are joined together or bonded together in a fixed ratio, right? To mention some common example, it's H2O as a compound, right? Because it is made up of what? Hydrogen and oxygen, which are different from each other, but they are in a fixed ratio where we have what? 2 hydrogen atoms with 1 oxygen atom in this molecule of a compound of water. Are we together? Right. So now let's look at our baseline activity, right? Let's look at our baseline activity. It says, state the correct terms for each of the following descriptions below, right? Number 1, it reads as follows: elements or compounds of elements that occur naturally in the Earth's crust. Number 2, layers that all have the same center. Number 3, the innermost layer of Earth. Number 4, the sphere of the Earth made up of soil, crust, and the upper layer of the mantle. Then number 5, the rock that is so hot and it has melted. Number 6, the rock name that comes from the Latin word for fire. Then number 7, the natural continuous process in which rocks form, are broken down, and reform over long periods of time, right? So I'm going to give you 5 minutes to complete this activity. Then after that, we shall meet together for corrections. Welcome back, grade 9s. We are going to look at the solutions together. But before that, let me remind you of our WhatsApp interactive number where you can contact us to send in your answers, comments, or any questions regarding this lesson, right? The WhatsApp number is 079 578 2908, right? So let's look at the solutions to this baseline activity. It said, state the correct terms for each of the following descriptions below. Number 1, elements or compounds of elements that occur naturally in the Earth's crust. And what do we call those now, right? We call those what? Minerals, right? Those are minerals. Number 2, layers that all have the same center, right? We say that they are concentric, right? Those are concentric layers. Then number 3, the innermost layer of the earth, that is the inner core, right? That is the inner core. Then number 4, the sphere of the earth that is made up of soil, crust, and the upper layer of the mantle, right? That is our lithosphere. Then number 5, the rock that is so hot and it has melted, right? Well, that one is magma, right? That is magma. Then number 6, rock name that comes from the Latin word for fire. That is an igneous rock, right? That is an igneous rock. Then lastly, number 7, the natural continuous process in which rocks form. They are broken down and they reform over long periods of time, right? That is the rock cycle, right? The rock cycle. So now, let me just give you a quick minute to copy down the corrections. Then after that, we shall continue to get into our main meal for today, which is mining of mineral resources. Welcome back again, grade 9s. Now remember, if you want to send in your answers for the upcoming activities, our WhatsApp number is 079 578 2908. Now let's continue with our lesson, starting off by highlighting what? The important terms that you're going to come across, right? So the first term that we have there is mineral, right? So what is a mineral now, right? Because we're talking of the mining of mineral resources. So a mineral is a naturally, right? I would like to highlight that part. Naturally occurring inorganic substance that has the same properties throughout, right? It has the same properties throughout, right? And it is naturally occurring. Then we have extract, right? What does it mean to extract now, right? To extract is to remove or to take out of, right? To take out of something, right? Then we have veins. And veins, now in this case, these are thin lines of solidified what? Lava, right? Solidified lava that have formed in the cracks, in other rocks. Then we have ore, right? And ore is the rock with a high concentration of a valuable mineral, right? And ore is a certain type of rock or it is a rock with a high concentration of a valuable mineral, be it is gold, it is silver, it is coal, and all the other minerals that we're going to talk about, right? So now, the mining of mineral resources. Now, let me ask a question now. Where does the mining of mineral resources take place, right? It takes place in such industries as these ones, right? As you can see in our picture, such industries that we call what? Mines, right? That we call mines. For example, in our country, we once had an issue with the Marikana mine, right? The Marikana mine is one of the mines in South Africa where we get what? Mineral resources, right? Another example now, right? Which is the Mponeng gold mine, also found where? In our very own province, which is Gauteng, right? So I like also the word Gauteng because it is a Sotho word that means what? In gold, right? So Gauteng is a city of gold, right? In that manner, and this is where we find what? Most gold mines. Are we together? Right, so in the process now of mining and extracting what? These mineral resources, right? We have to get them from what? From their core ores, right? There are certain rocks that are rich in these certain what? Valuable minerals, right? So there are processes that take place in mining to be able to extract the minerals that we are looking for, right? So looking at this picture, for example, right? There's some burning of what? And crushing of this rock where to be able to extract the mineral from it. Right. So now, the lithosphere is where we find now the most minerals that we are talking about here, right? So the lithosphere contains many different minerals, right? If you remember from our previous topics, we said that the lithosphere is all the solid rocks and soil of our earth, right? So this is where we dig. This is where also we get these minerals that we're talking about, right? This is where the minerals are contained in our lithosphere, right? So from our lithosphere, we get minerals such as gold, platinum, diamonds, coal, lead, copper, potash, and even sand from the lithosphere, right? All these different minerals, they are useful in their different manners, right? So if you think of gold, gold is used as jewelry. Gold also is used for our taps at home, right? Diamonds also for jewelry and also for its strongness, right? To be able to drill into other objects, right? Coal as well as one of the important minerals is important because it serves a good purpose for generating electricity as well, right? So all these different minerals, we get them from our lithosphere, all our solid rocks and soil of the Earth's system, right? This is where we dig, this is where we mine and get these minerals, right? As you can see here, we have an example of what? Of coal being mined, right? So some of these minerals now, they are mined and they are classified as elements, meaning they have the same properties throughout, right? They are classified as elements, right? For example, gold is an element and also silver is an element, right? They are classified and found as elements from what? From our mining industries, right? But some of these also, some of these minerals also, they come as compounds. By compounds, we mean what now? We mean that they are formed by two or more different elements that are chemically fixed or chemically bonded in a fixed ratio, right? So it's either we find these minerals as elements or as compounds, right? So the different elements, as I've mentioned, are gold, are platinum, diamonds, coal, lead, copper, potash, and even sand can be mined from the lithosphere. Are we together? Right. So now let's look at this example here, right? This is an example of rough diamonds that are extracted from a mine in Angola, right? So some of these minerals, they come as raw as they are, and they do not have to be extracted from an ore, right? So rough diamonds as well, an example of what? Of such minerals, right? These examples now, so these diamonds are an example of minerals that are extracted from a mine in Angola, right? And also now we have what? A diamond mine where in Kimberley, right? In Kimberley, and this is an example of the largest octahedral diamond that is found in the mine, in the diamond mine that is found in Kimberley, South Africa, right? So this is the octahedral shaped what? Diamond that is found in those mines. Right. So now, some valuable minerals are found in igneous rock, right? Remember now the formation of igneous rocks, right? Igneous rock, they form as a result of what? Of volcanic activities, right? When the magma solidifies and it does what? It solidifies and it forms such a rock, which is an igneous rock, right? It either solidifies exclusively out of the Earth's crust or within the Earth's crust, which is intrusively so, right? So, for example, right, we find platinum, we find chrome, we find gold, and also we find diamonds in such rocks, which are called the igneous rocks, right? So minerals such as gold are also found where? In sedimentary rock, right? So when there is soil and weathering, soil erosion and weathering, right? You have those pieces of sediments packing up together to form this type of rock, which is sedimentary rock, right? So those pieces now also, they come together with what? Pieces of gold, right? Gold ash, right? Then they find that we found our gold where? In our sedimentary rocks, right? And gold forms in igneous rock as well, which is deep inside the Earth's crust. So hence I'm saying due to soil erosion and also weathering, right? We have those pieces of rocks that are called sediments that are going to be deposited, and also they're going to be to become compacted together to form a sedimentary rock, right? So in that process, you find also pieces of gold, right? Or gold ash, right? You find pieces of gold in that sedimentary rock, and also as a result, gold can be found also in a sedimentary rock. Are we together? So the gold occurs now as thin lines in the rock that are called veins, right? When this gold now is deposited inside these rocks, it occurs in these thin lines in the rock that are called veins, right? So think of veins of the body, right? They are as veins as well, like that, right? To illustrate or to show what? The gold, right? That is in the rock, right? They form these veins. So hot fluids flowing through the cracks in the rock are deposited, and the gold, it forms what? The veins, as I've said in the previous point. Right. So also gold can be mined from these veins, right? We can extract gold from these veins of these rocks, right? But usually the particles of gold are eroded and washed away, depositing what? Sedimentary layers which form the gold reef, right? So now, here is the vein that I'm talking about, right? Look at this rock, right? This is a whole what? Rock. And now on this rock now, there is a vein that is a thin line of gold, right? So also now this gold can be mined from this rock, right? By breaking what? The rock to be able to extract this gold from the rock, right? So we have also gold mines like Sibanye Gold Mine, right? Which is also in Gauteng, right? It specializes with what? With gold mining. Right. So now, as I've said that now, some of these minerals, they come naturally as they are from the lithosphere, and others need to be extracted from rocks that contain high concentrations of these valuable minerals, right? And the rock now that contains this high concentration of valuable minerals is called ore, right? This ore now is where we find or extract our minerals. And the process of extracting the mineral from the rock is so expensive, right? It is so expensive and is only worth the effort when mineral concentration is very high, right? So also now the process by which the ore is removed from the crust is called mining, right? So the whole process now of removing the minerals from the lithosphere, from the different rocks, is called mining. And also there are many types of mining, right? Like sand mining in riverbeds, gold mining, diamond mining, right? And more often, the ore must be removed so that we are able to get our minerals from the rock, right? So the ore must be removed from the parent rock and taken away for further processing, right? To be able to extract the mineral and get it in the shape that we want to get it, to have it, right? So some minerals can be used in their natural form, right? As I've said, such as diamonds, right? They can be used in their natural form, right? But we only need to shape them. We need to only clean them, right? That's only what we need to do. Whereas other minerals, they need to be refined in order for us to be able to use them, right? So diamonds, for example, they can be used in their natural form, right? They are used for their hardness in drilling and cutting what? Machines, and also for decorating where? In jewelry, right? Can be used for decorating, and also they can be used for their hardness, right? In drilling and cutting machines. So another mineral that can be used in its natural form is potash, right? Potash now can be used as a fertilizer for agriculture, right? Because it is rich in potassium, right? So as I've said, that other minerals can be used in their natural form and others need to be refined in order for us to be able to use them. So now sand also is another example of a mineral that can be used in its natural form, right? Because it can be easily removed from a riverbed and washed and also used immediately to build, right? Immediately to build houses, immediately to build any form of infrastructure, right? So it comes in its natural form as well from riverbeds altogether. So as I've said now, other minerals now, they need to be mined and processed in order for us to be able to use them, right? So these kind of minerals, they require certain processes such as chemical or physical methods to be able to extract them from the ores. Are we together? So iron, for example, right? Iron is extracted from iron ore, right? Iron is extracted or taken out from or removed from what? Iron ore by means of chemical method, right? And also gold is removed from gold ore by means of physical methods, right? And we're going to look at these examples one by one, right? But for now, I want us to look at activity one to try and answer in as far as we understand, right? So number one says, from which part of earth do we extract valuable minerals? Number two, what do we call the rock that contains high concentrations of valuable minerals? Then number three, choose the correct word. Ore is removed from the earth's crust by mining, sorting, or sieving. Then number four, list two examples of minerals that are used in their natural form. So I'm going to give you 5 minutes to complete this activity. Then after that, we shall mark this work. Welcome back, grade 9s. I hope you had enough time to copy down this activity and write your answers. Right, now let's look at the solutions. Number 1, from which part of the earth do we extract valuable minerals? Right, that is the lithosphere, right? This is where all our mining takes place, right? This is where we extract these valuable minerals. Number 2, what do we call the rock that contains high concentrations of valuable minerals, right? That is an ore, right? O-R-E, ore, right? Then number 3, choose the correct weight. Ore is removed from the earth's crust by mining, right? By mining, right? So you have to circle or underline the correct weight. Then number 4, list 2 examples of minerals that are used in their natural form, right? We have mentioned them in the previous slides. Those are sand and also diamonds, right? So let me give you now another quick minute to copy down the corrections. Then after that, we are going to move on with our lesson. Welcome back again, grade 9s. I hope you had enough time now to copy down your corrections. Right, so now we're talking about what? Some of the chemical and physical methods of refining these minerals, right? So now, we're talking about iron, right? Being removed from iron ore. Are we together? So iron is refined from iron ore in a chemical process called smelting, right? Smelting, where a certain machine called a blast furnace is used together with limestone and charcoal or coke or carbon, right? That is used in order to refine this iron or for us to be able to remove the iron from iron ore, right? So this certain blast furnace that we're talking about now, it is a vertical shaft what? Furnace, right? It produces liquid metals by the reaction of a flow of air introduced under pressure into the bottom of the furnace with a mixture of metallic ore, coke, and flux fed into the top, right? So now, what happens here, right? All the components are placed on top of the furnace, right? Where they're going to experience a lot of pressure, and we're going to produce what? Liquid what? Iron, right? So we're going to look at the process in the coming slides. Right. So it also involves now dissolving the ore using a suitable chemical and then removing the mineral from the chemical solution, right? Then we have the mineral as we want it, right? So heat and oxygen can also be used to remove the impurities from the minerals, right? Or to refine the minerals from the steel, right? So now, usually steel is stronger and lighter and more resistant to rust than iron. So I want us to look at now the iron smelting reaction, right? So now let's go back to our term 2, right? When we're talking about chemical reactions, right? This is how a chemical formula of this reaction is, right? So we have the iron oxide now. We reacting with carbon, right? As our reactants in order for us to be able to refine iron, right? We have this iron oxide plus carbon to form now what? Iron, right? Iron and carbon dioxide as our products, right? Then the iron now, we have it is removed from the iron ore, right? So as I've said that most minerals are extracted from the Earth's crust in the form of ore, right? And other minerals require chemical or physical processes to extract the minerals from the ore, right? This is just a reminder. So let's look at the issue of gold now, right? Gold now is found in alluvial deposits and it is extracted by physical processes, right? So these methods were used mainly in the early days of gold discoveries and they are still used even today, right? It is one of the easiest ways to separate the gold, right, from its ore. The processes are now gold sluicing and penning, right? These are the two methods that are even still used today in order for us to be able to extract gold, right? So this is what? A gold sluice, right? A gold sluice that is used to be able to extract gold. Right. So also now penning is one of the processes that is used to extract gold, right? So it involves taking sand and gold dust from a sluice box, right? Or sometimes gravel directly from a river, alluvial sediment, into a wash basin or pan and swirling it around, right? As we swirl it around, what happens? The gold drops from the bottom. As it drops from the bottom, what happens? The gold dust and flakes can be collected from the bottom of the pan, right? So now, as you can see, it is an easy process that helps us to be able to extract gold from its ore. Right. So now to mention some of the chemical methods of extraction, right? Many minerals are mined through chemical methods, right? As we've said. So it involves dissolving the ore using a suitable chemical and then removing the mineral from the chemical solution. Are we together? So we find that heat and oxygen can also be used to remove the impurities or to refine the minerals, right? So here is a picture now of a blast furnace that we're talking about, right? As you can see now from our picture, we have iron ore, limestone, and coke that are entering the furnace, right? As they enter the furnace, they experience some seriously hot air, right? Some extremely hot air, right? Which is going to be able to melt everything together and also to refine our iron and receive what? Our molten iron from the bottom of the blast furnace, right? So this is where also a picture of a bended iron stone where we are able to extract what? Iron from it. Now, moving on now to mining in South Africa, right? Taking this mining topic into our context, right? Into our context. So mining is a very important activity for our economy, for our country as a whole, right? And has helped our country to form an extensive infrastructure. Today we have different bridges, we have different buildings because of what? Our mining activities in the country, right? We are able to increase our wealth and also to improve our economy to be able to build such infrastructures, right? So in our country now, we have approximately 60 minerals that are extracted from about 700 mines and quarries around the country, with some of these being exported to 100 countries across the world. Are we together? So South Africa's mining industry has also now the 5th largest economic value in the world, right? So it increases what? Our wealth as a country, and also it improves what? Our economy, right? So now, as we've said that we have now nearly 90% of the platinum metals on earth, 80% of manganese, 73% of the chrome, 45% of the vanadium, and 41% of gold, right? So now, here is a big issue that I want to highlight in the form of a case study, right? The issue is of current time. Also this year we experienced the issue of the Zamazamas, right? So here is a case study to see how these Zamazamas affect the country, right? So on the other hand, the country is faced with a large problem of illegal mining, right? The Zamazamas. So historically, illegal mining was associated with derelict and ownerless mines, right? However, it is now having an impact on operational and licensed mines. It is estimated that the South African economy and the mining sector has lost approximately 49 billion rands in 2019 to illegal mining, right? Said the mineral resource and energy minister, Gwede Mantashe. So illegal mining has come under sharp focus over recent weeks following the brutal gang rape of 8 women near a disused mine in Krugersdorp in July, right? So now, I want to focus more on the issue of the money, right? The South African government has lost up to about what? 49 billion rands in 2019 to illegal mining. That is a lot of money that could have went to bettering our infrastructure, bettering our trade businesses, and bettering our economy as a whole. Are we together? Now, let's also highlight some of the environmental impacts of the mining activity, right? So it is not all good, right? But can have negative impacts on our livelihoods, right? So mining poses many threats to the environment and our health, as it can scar the land, it can destroy natural habitats for trees, for birds and so on, right? Can destroy the water by polluting it, can pollute the air, and also it produces what? Large amounts of waste, dust, and poisonous chemicals, right? And also it damages what? Places with high tourist or cultural heritage value, and also it contributes to the loss of farming and wildlife environment, right? Where we have what? Vegetation and soil being removed from the land, right? So this is pictures showing the negative impacts of mining activities, right? As you can see, the water is contaminated, the water is polluted, and also it is a natural habitat for other living organisms, and now it is damaged, right? And also mining gives birth to what? To mine dumps, right? So when mines excavate and process ore, there is a large amount of crushed rock material left over, right? And this is normally stored in huge piles called these mine dumps I'm talking about, right? So water that soaks into the dumps dissolves these hazardous chemicals and takes them into streams and into groundwater, right? Contaminating the water as well. So people living near mine dumps may have significant what? Health risks, right? They may have significant health risks. So as a result of inhaling this mine dump dust and coming into contact with the polluted water, right? So they can contain another dangerous pollutant, radioactivity, which can react spontaneously, right? And it can contaminate the air, soil, and our water. So now looking at the pollution of our water resources, right? Mining takes place in direct contact with nature, right? And nature also has to do with water. So it is very difficult to prevent chemicals coming into contact with water, plant life, and in that way with all the cycles of nature and human lives as well, right? So life as well as a whole is affected by mining, right? In terms of our health, in terms of the destroying of natural habitats, and also pollution, right? So when mines fill up with water and that water begins decanting or seeping out of the mine, acid mine drainage occurs, right? Where acid mine drainage causes devastation to the water bodies it enters, right? So this is a result of what? Acid mine drainage, right? As you can see now we have what? Too much contaminated and polluted water. Right. Now moving on to our activity 2, right? It says list up to 10 minerals obtained by mining. Number 2, describe some of the benefits South Africa has enjoyed because of the mining industry. Number 3, explain why these benefits come at a cost, right? So I'm going to give you 4 minutes to complete this activity. Then after that, we shall mark together. Welcome back, grade 9s. Remember, our WhatsApp interactive number is 079 578 2908 should you want to send in your answers, questions, or any comments regarding this lesson. Right, let's look at the solutions now. Number 1, list up to 10 minerals obtained by mining. Right, the answer is, let's start by mentioning the most common: gold, coal, platinum, diamonds, silver, sand, potash, salt, copper, and iron. Right? Then number 2, describe some of the benefits South Africa has enjoyed because of the mining industry. Right? As I've said, the mining industry has brought a great deal of wealth to the country, right? Which has allowed us to have a strong economy, well-developed infrastructure, and a high level of technical expertise, right? Then number 3, explain why these benefits come at a cost, right? This is because of what? There are environmental and social impacts that come with mining, right? There are negative environmental and social impacts that need to be considered when mining, right? So I'm going to give you another 1 minute to copy down the corrections. Then after that, we shall wrap up our lesson. Welcome back, grade 9s. Now we were going to head into our WhatsApp section, right? But it seems like there is no interaction today on our WhatsApp interactive number. But please, next time, remember this WhatsApp, it will always show on our screen. It is 079 578 2908, right? So let's keep this WhatsApp section and head on to the lesson summary. Right. So today we're talking about the mining of mineral resources, right? So we said that the lithosphere now is where we get all these mineral resources, right? The lithosphere being our solid rocks and soil of our earth. This is where we dig. This is where we get all our minerals, right? So we extract valuable minerals such as gold, platinum, diamonds, coal, lead, copper, potash, and even sand from this lithosphere, right? And also some of these minerals are classified as elements. For example, we have gold and silver, right? They come in the form of elements, and some are coming in the form of compounds, right? And here's an example of coal that has been mined, right? And also we mentioned that most minerals are extracted from the Earth's crust in the form of ore, right? Whereas other minerals, they require chemical or physical processes to extract them from the ore, right? Whereas other minerals, they can be used in their natural form, such as diamonds or sand, right? And also we highlighted the mining in South Africa, right? We say that it is important for our economy and it has helped our country to develop extensive infrastructure and as well as to improve our economy as a whole, right? We said that we have approximately 60 different minerals that are extracted from about 700 mines and quarries around what? The country, with some of them being exported to 100 countries across the world, right? And also the South African's mining industry is the fifth largest economy, as the fifth largest economic value in the world, right? And also we said that all this wealth or our economy is based on these mining activities, right? But also on the other hand, we are still struggling, right? Because of we are still facing what? The Zamazama issue, right? Which is illegal mining. And in that case study, we found out that in 2019, we lost approximately 49 billion rands to illegal mining, right? So now I hope you have enjoyed today's lesson. Let's meet again next week when we're talking about the layers of the atmosphere, right? When we're talking about the atmosphere, the troposphere, stratosphere, mesosphere, and the thermosphere. So I hope you have enjoyed today's lesson. From me to you now, thank you and goodbye.